Swamp 2.0 is an autonomous plant watering robot that ensures users consistent plant care. The robot accomplishes this by navigating through the environment, aligning with the plant's pot, and watering the plant accordingly.
Now let's introduce you to the mechanical architecture behind Swamp 2.0. The major components of the robot are the soil sensor, which will be used to probe for soil humidity, the articulated arm to position the soil probe in the pot, the depth camera to drive between the pots and to align the robot, the Jetson Orin Nano, which is where the main processing will run and execute programs, the water tanks, which will hold pumps and water level sensors. The arm has 4 main joints: the prismatic tower, revolute shoulder, revolute elbow, and prismatic end effector. The tower lifts and lowers the shoulder joint vertically. The shoulder lifts and lowers the elbow. The elbow rotates the end effector to line up perpendicularly with the soil. The end effector extends the probe.
Now let's introduce you to the communication architecture for Swamp 2.0. For development, we upgraded to ROS 2 and ran our state machine code on the Jetson Orin Nano. Key components interface directly with the Jetson, while smaller components such as motors, pumps, and the wheelbase connect via microcontrollers such as the ESP32 and SAMD21. Now let's introduce you to Swamp 2.0's companion app, the Swamp app.
The Swamp app lets the user map their environment, create and edit plants on their map, and create watering schedules for their plants all from their phone or computer. The mapping page lets the user map their living space to put plants on. Users move the robot using buttons, and there is live map progress and a camera feed from the robot. The plants page lets the user define the plants in their space. Plants are drag and droppable, and the user can set and modify the position and moisture each plant needs. The schedules page lets the user set the robot's schedules. Users can set and edit the day, time, and plants to be watered.
In the mapping section, a static map of the area is created while the user teleops the robot. The robot enters and exits the mapping state by the app. The robot uses a ROS2 package called RTAB Map, which extracts visual features from the depth camera to create the drivable and non-drivable spaces on the map. In the driving state, the robot will use the camera to localize in the environment with the map created in the mapping state. After localization, the robot starts driving using a ROS2 package called NAV2, which handles path plan and obstacle avoidance. When close to the plant, the robot relies on its object detection model to identify the pot.
In the aligning state, the robot will use the detected pot centroid to align itself with the pot. The robot will use the depth measurement to align itself. The arm will align itself so that the moisture sensor is perpendicular with the top of the soil using inverse kinematics. In the watering state, the robot will gather the moisture reading and water the plant according to the user's preset preferences. The robot will then retract its arm and drive to the next scheduled pot. If the water tanks are low after visiting a pot, the robot will go to its home location to be refilled.
Additionally, if there are no scheduled plants remaining, the robot will drive to its home location in the drive to well state.